Hi everybody, good morning. I'm continue doing videos for this new part of TryHackMe Cybersecurity 101. This one I'm doing hashing basic. Okay, for hashing we'll using Hashcat for decryption, decoding. I'm using now. I already SSH to the machine using this login. I'm inside the machine. That is the machine, and then. I'm also SSH to it from my computer, so I'm also here in the machine. A reason because some hashes they might take long in attack box depend on the memory of the machine, so I'll use my own computer for that. Okay, let's start and see how things will go. Is this only subscriber? Sorry. So a hash function. Again, this is introduction security. It's any one of you who did computer security plus or network plus, you will get this information. Okay, let's do test here in this computer because hexstamp. Let's create. Let's say vim test. Okay, let's use the same file1 .txt. Let's put anything on it. The hex. Let's mute this. I don't like this noise. Hex them, for example. These also hex edit if you want to edit. Sorry. What do we called it? File1.txt. Yeah, this is also software you need later on. What is it? When you do, sometimes we need to bypass some image upload or things like that. Usually this introduction to show you, okay, this is a binary and decimal things that if you know, but there's 8 bytes and there's a bit for 101, and then is this the byte for 8. How many is 2 this is the byte, so each letter corresponds to a byte. Usually this is the explanation how the hashing work. So most of the hashing, the old one is MD5, then the SHA-1, 256 and 512. Hashing, of course, is how to hide things. It's reversible. So for example, if I say SHA, let's see what SHA we have. Let's say the strongest one we have now, 256. So of course this number is reversible. In general, of course, it's high probability that you can't take this and come back to the file. So it's one-way function. That's why we call it is one-way function. And then you have the term collusion. Collusion, of course, what it means. Like where they talk here. If you have what is the example of 12 holes and you have 21 pigons, so there will be collusion. Some pigon will be together. The same here. That's what happened with the MD5. These are the collusion MD5 MD4. So it means you can have two files, they can have the same hash. That's why, for example, they upgrade from SHA-1 to 256, and now we have this 512. The probability to get two files they have the same hash is very less. You can read about this. This is this is the math usually for binaries. Like we have a 2 2 4 16. Byte is 8, so you have 1 0 0 1, then you have 8. For example, if you go here, let's go to machine. They took us to go to task 2, hashing basic, task 2, and then they ask us for passport. So if you get SHA, you have that. They ask us for 256. So if you go 256, where is this passport? Passport, of course, we get the SHA is longer than MD5. If I do, for example, an MD5 here, MD5 is 128. 128. If you count them, you find how many we find here? 24. 1 2 32. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. 32. 32 by 8 is how many? By 4, because it's hex. This is a hex. So 5, it's 4 5 bits, so 32 multiplied by 4 is 128. This is 128 bytes. That's why, for example, in this question we say what is the output size in bytes of the MD5. So it's 128 divided by 8. That's why I said to you hex and divide by 2, divide by 8, so you get 16 by 8, because 16 multiplied by 8, 80, 8 by 40, 48 to 128, so you can count them there. 120, this is 32 by 8, by 4. I don't have to explain, guys. It's this bytes and bits and yeah, it's something like that. We got the hash for the MD for the SHA, and then if you have 8-bit hash output, how many possible hash value? Yeah, this is the math things. It's 2 power to 8, which should give you 256. No, what's this? For example, here, hashing has many in the user service security. Stories when secure password storage. Of course, this is always here. Sometimes you have to tell you password was stored in plain text and things like that. Stored in plain text, deprecate or use MD5 or something, so weaker algorithm. Like for example, if you store password in plain text, usually we get this raw queue. You always find it. For example, if we go to computer here, raw queue is we know WC minus L. Let's use a share word list. Raw queue is in this one, so we have how many raw queue has? 14 million output. And then of course, if you go to just the head of it, let's say the head, we can couple of them, so almost. And then let's test. For example, what is the 20th password in the 20th? So what we do, minus n20. I don't think if this comment the 21, so yeah, it's the last one. So we just do this and then tail n minus n1, so you get the password, so you get the last one. So you get it first 20 and then cut the last one, so you do the tail, so you just get this one. And then using hashing for secure password storage. Of course, here you're talking about yeah, this is another trick they usually, because this is plain text, but if you have password in database hashed, for you to run every time to check the password, then hash and check it takes time. That's why, for example, now they created a rainbow table that already contain the hash, so it's easy for you to just compare it. For example, crackstation, hash.com, Intel use a massive rainbow table, and that's how they get the password very quick when you give them the hash. Protecting it against rainbow table, we add salt. That's what usually now the modern things is using the salt. The salt is like this one. It's very explained, very good here. So if you have the password, then you have either password and what is it? No, we add the unit salt to password. So it's like a random thing, the password, and then calculate the hash value. So basically, if someone, even if they find this, they don't have the salt, so it's not easy for them. And then you don't use encryption to store password. Get always installed using encoding, hashing, because if you store password with encryption, then you need to find a key to store a key. If someone find the key, it means you found all the password. Now, so manually check hash using the rainbow table above manually. So it's 4C59 4C59 4C5. So this is the one. So it means this is manually checking, and then crack hash using online tool. This is look like I don't. It look like an MD5. So let's try it. Not found. Okay. What's the other online tool they gave us? Hash.com. LGUNVG, if it's the correct, submit. TryHackMe. How come this crackstation couldn't find it? Okay, it's not in the rainbow table. Okay, should you encrypt the password? As we said, we don't encrypt password when you store them. We hash them, so it's nay. And then what's this? This one we're going back to Kraken now. Linux password is in the shadow. This one everybody knows. If you look ETC shadow, no shadow. They don't show here. So and then the encrypted password field contain the hashes in passphrase with the component prefix algorithm ID. Okay, this is the way, for example. The prefix make easy to recognize Unix and Linux system. We'll check this now. It's easy to decrypt 5 algorithm. For example, $ys ys script is a scalable hashing. This will understand now when we go to a hashcat. Let's take a moment. Don't get confused too much about this. Modern Linux example. As you do, let's say consider the following line format for modern system: shadow password. Let's get it from here. So we are I'm already root, so cut etc shadow grep what user we have here. No, iodine. How the hell you getting? I forgot. I'm going confused now. Where do you get this from? I don't know. Let's continue for now. I'm getting but confused. So, our friend Windows, the NTLM, MD4, all that. This is what we'll work with in this room. What is the hash size of Y script? What was that? Rest online, check manual page, man5 crypt. Man5 crypt. What? Man5 crypt. Why don't... Let me see my computer. Man5 crypt. So it's TryHackMe attack box is an old one or something. So in my computer, I think I have my Linux is not old. So the question is why es script? Why yes? No yes script. Yes script is scalable password hashing scheme designed. Designed by SAL1 designer, which is based on the Hash size is 256. So we got this. So let's go. So let's see if this is in the in the machine they give us. Let's see if it's an old machine or this one. So the attack box is old, so you can use this one, so it's not need another computer. We search it online. So yes, crypt. So we have it here. So it's you can use the machine they gave you, so it's fine. So let me go out of this. What is the hash? What's the hash mode listed for Cisco ASA MD5? Let's search now in these things. Let's zoom it. Control F. It's 2410, so we can show is this one. That's how you use Hashcat later on. Let's continue, and then we can test later on. And then what hashing algorithm to use in Cisco iOS if it start with $9? What did the $9 Cisco iOS $9? Okay, Cisco iOS, not this one. We're looking for $9. This is $9. So so it should be this one, script. Okay, then password cracking, and this is the test we got, because I got some users, they said when they try the attack box it gets slow. So let's try and figure it out. We already, okay, we have the list of the password we use is ROQ. In this room using Hashcat, not John the Ripper. Cracking password with GPU. This is also you need to have a good computer. The password is complicated. Now Hashcat is always Hashcat -m and then the hash type, attack mode. Like for example, is for straight trying one password from wide each time. So this is one we use for now. For example, you use this. We'll treat the hash as bcrypt and try password in ROQ. So let's try for example the first one. Use Hashcat to crack the hash. First of all, I'm not think we need to use a machine. What task 6? Let's go to task. Sorry guys. What file? hash1. At hash1. Let me get this hash here. Some users, they said the attack box is slow. I'm not sure. My premium version, let's see. hash1.txt. Let's see if hash1 can work here. We have $to $8, so we need to know what this is. Another, I think it's inside the attack box, another one called the hash ID. No, it's not here. Okay, so if we do now, we follow now the hashcat command, hashcat. So we need to have -m. We need to find what type of hash this one first before we crack it. So we know it's $2A. So maybe you can just say, they already did an example here. Let me see. Let's see what we got if we find it's $A. We find it's bcrypt. Let's see what we got here exactly. $2A $0. $0. What else? 6. So we have two possibilities here. Like it's a bcrypt, which is 25800 or 25600. What else we have? It's running in bcrypt some kind of because not 12. That one look like $0. So we can say that one maybe is not that one. $0 is here too, is bcrypt 3200. $0.05. $0. The first. So it's bcrypt 3200 or decrypt these ones. I'm not sure which one we should use. This one look like straight like ours. Straight. This is 28400. This one also looks more straighter like ours. 3200. Yeah, okay, my computer, I have something here. Hash1.txt. Oops. Let me copy the whole. Let me close this. Because there is a command you can install it. For example, they call it hashid. If you install it in Ubuntu app, then install hashid and then you just hash1. So it tell you analyze. It's either bcrypt, bluefish, openbsd. So most interesting is the 3200. Did you find the 3200? Yeah, this is bcrypt. What it said here? Bluefish, openbsd, or Waltable, or bcrypt, one of them. And now we have a bcrypt 3200, we have a bcrypt md5 and SHA, and then we have bcrypt SHA-56 and 3200 bluefish. They talk bluefish here, so we can say the 3200. Let's try the 3200. Let's say M3200. You need to edit my broad first password. Let's see if attack box can get this one faster. If not, we use my machine. OQ. Let's let it run. Let's see if he can find it. Let's wait for it. Let's get the next one. The next one, use Hashcat to crack the SHA-526 hash. Okay, let me use my machine for this. Vim hash2.txt. Now, what's the SHA-256? What's not freezing now? What's the number for SHA-256? No, that one is not SHA-5. It's 1400. So if I go hashcat minus m1400 minus a0 hash2, where I'm saving my raw queue, I think is in hack the box raw queue. Let's see if we can find it. Let's wait it. I think it's 1400 for the SHA. He couldn't find it yet. How are you, my friend? You froze. Okay, let's there. He found it here. It's cracked. It's Halloween. Okay, let me do this because it seems I want to wait for it. So minus M300. Let's do this because I want 3200. The file is hash1.1. Let's see if we can find this quickly. I'm using now my machine here, so this one is the attacks box is still running. So let's see if oh, he cracked it already. So crack it. Let's not waste my energy here in my computer. He cracked it. What he found? He found this one. That's the crack. So also attack box can work. So it's not like heavy you can think. The next one is use Hashcat to crack. Oh, this won't look long. Let me use my computer for this. Vim hash3.txt. Let's use hashid file and see what it tells us. Okay, what it say? It say that it's SHA-512 crypt. Okay, so this one SHA-512 crypt. Let's confirm in conf. We said crypt. Search Soprano IS Toolfish base 64 pass. Where is this crypt now? No, I forgot what the point is. It SHA-512? It's like he knows about it straightforward. Let it's SHA-512. But where is why don't see the IS? Which one we should take now? Serpent, Tollfish, base 64, GPG, IS. Okay, I did this room and then I forgot. Let's see if we get the $6 search about it. No, the G. Ah, this. Yeah, why I couldn't find it when a couple letters? So it's SHA-5 secret crypt, like the same as this one. What he detected, so it's correct. I was searching with the. So it's 1-800. So okay. So we can say 3 1-8. Where are you going? And it's 1-800 hashcat #3. Let's. Whoa. What happened here? #3 and then 1-800. Let's run it here. My computer be faster than using that one. Let's do the last one in attack box. The last one, what's hint here? You will need to use an online service. Okay, so I think it's an MD4 or something. The crackstation. Okay, crack it. Fun for you. It's an MD5. Okay, this one is still running. Let's run it. Let's continue. Come back to this. So we got this, that, but I left this one. Hashing integrity checking. Yeah, we do the integrity checking. When you download something, always they tell you download and check your hash. So usually this is what's this? Hashing can be used to check that file haven't been changed. So usually we do this. You can feel this password is not easy to find. It's my computer fan is oh, you found it already. Hashcat cracked, and he cracked it is a spaceman. So we have that one, and you can see I can hear my fan. My computer fan is a is doing a noise. So we have that password. So we got that spaceman. Yeah, usually this when you download anything you do the hash. So this one, guys, is straightforward. The following step give you the fair idea of HMAC, key hash message authentication code. This is usually if I'm not like for email signature or something like that. Okay, this is that you can, yeah, it's the idea just to understand it, not really technically speaking. The HMAC function is calculated using the following. So, as I said, because it's an entry-level beginner part, you don't need to go deeper how things work. Just understand they exist, how they work, and that's it. So don't spend too much on it. And then the question is task 7. Let's go to task 7. Okay, and then we have that try. That's what they said. Is because usually if you download software library or something like that, they always tell you SHA-256, SHA-256. To know, for example, what you download is not like someone modified or something. So you download or something change in transit or something like that. So you always check the hash. Then what's the hashcat mode number for HMAC to file key pass? Let's go there. Control F, key pass. So it's this one 1750. So that's one equal. This is in case you try to decode. And then what's the next one? Conclusion. So we got the hashing, and then you convert data to one form or another, make it impossible with specific system. So this is encoding. We did the hashing and encryption, and then we have another type of encoding common used when sending or saving data. The base 64. You know, always we use this one. There's a question now. Only encryption which is covered in previous room protect data. Yes, that's true. Yeah, it's good to check. John the Ripper, it's also good to have this room to check it. Let's see what's that room. No, what task now? Task 8, cd task. Okay, cd task 8. This is the room of, no, where is the room? The link is wrong. The room you try to access doesn't exist. No, this is the link is wrong. We need to report. TryHackMe, you give us a wrong link. John the Ripper, that's the correct basic. And what's the link they give us here? John the Ripper 0. I need to go to complain in Discord. So they said use base decode to decode, save it and decode this. Usually you just do decode and pass it to base 64. And then minus d flag to decode it, and there's encode decode. It's base 64 always needed in when you do CTFs. It's always okay, guys. Thank you very much, and hope you like it. I did it because I saw in Discord some users said they have issue with the attack box, and I think the last one, yeah, it was heavy. I can see my fan was flipping around a little bit. Okay, guys, thank you very much, and have a good day.